Hey, so my name is Jerome Baron. I'm working in imec as business development manager for our imaging activities. We are here in Photonics West to demonstrate our recent products in the hyperspectral imaging space. So just as a quick demonstration here of our capabilities, we have a factories where we can process on top of any commercial image sensor wafer spectral filters. This is based on our 200mm factory. And as you can see, we can deposit different patterns, different spectral narrow band filters of different colors with a lot of different design possibilities. You can deposit on this specific example about 128 different colors. The filters are extremely narrow, but enables the sensors to filter a very slight part of the spectrum. So from the sensor, of course, they are first built collectively on a wafer. Then we can dice and make a chip sensor solution. At the end of the processing, we dice, package, and test and calibrate the sensor so that we can supply your partners with chips that can be integrated into commercial camera boards for development and also production. This is an example of two designs we have realized for the machine vision industry. One is a line scanner that can scan on conveyor belts for food sorting application, for example, or for remote sensing in space imaging. The second example is a snapshot. It's one of the first, I would say it's the first snapshot, the hyperspectral sensor solution that can capture hyperspectral data at video rates. So from the sensors now, I would like to show you who are the current partners of imec for the integration of this unique sensor technology. So from the sensors, which can be delivered and mass produced in imec, then we can integrate the sensor into standard cameras. And here, for this unique event this year, we are announcing 4 of our partners. To start with, I will show the cameras of imec. So they integrate our sensors into this dual camera link camera, which is very high speed and focusing on medical and global security surveillance markets for this type of technology. We have another partner in Italy, which is building a very advanced machine vision camera. This company is called Tatile. They embed a lot of intelligence in the camera. You have an FPGA and a CPU that enables to do a lot of processing steps inside the camera so that the signal out of the camera is simplified and can interface directly with standard machine vision OEM solutions. Then we have a partner in the Netherlands called 3D1 that has developed this very compact camera that can be a very nice form factor ultimately to fly in UAVs for agriculture applications when you want to screen the fields and look at crop status, for example, and analyze how much fertilizer is needed on the field. And then our recent partnership has just been announced with BaseSpec. BaseSpec is a spectroscopy company in the Bay Area here in USA. They successfully integrated our snapshot sensor into this OC2000 camera, which was a finalist in the Prism Award this year. This camera is the first proof of concept that you can do and integrate hyperspectral image sensor into a very compact form factor. As you can see, you have the sensor with the lens, and you have a display and a software running under Android where you can program different apps, where you can transform the data from the sensor and analyze the spectrum directly with the touch interface. So this is for our application partners. And of course, this sensor technology is poised to grow in different types of camera, different electronic devices that will range from agriculture to machine vision, medical imaging, and global security markets. So what can we do with those cameras? An example which is quite simple to explain is shown here. We have prepared 4 different types of leaves. They are all green, so of course your eye believes they are just real leaves, but actually no. Some are made out of plastic, some are made out of paper. They are printed, it's a printed paper leaf. Some are real leaf with chlorophyll content in it, and some are tissue leaf. Of course, it looks like all green on the standard camera. The question now here is to see what type of spectral response can you observe under the type of hyperspectral sensor we have developed. So I will invite you to scan it and have a quick look at the spectral response from it. So I will scan right now with an evaluation setup here, the sample. It is going through the camera to integrate all the different information, the spatial and spectral information from the image. Now the scan is done. And we can move here to see the image data cube. So here we got an image which is 4 megapixels, but it's a stack of images through different wavelengths. We have 128 wavelengths. So for each spatial point here, we can see what is the spectrum. So here we go. I will sample the spectral information from the different spatial points here. So here we see our plastic leaf. So I will sample one point, different point. You see a specific spectral signature, which is varying a little bit. You have a very specific response, which is typical of a certain type of plastic. Then we have the tissue leaf here that has a different reflectance and different peak locations as well. Then this is a paper printing leaf, which has a that has a red edge around 750 nanometer. And here this is a real leaf which contains chlorophyll. As you can see, the spectral signature of chlorophyll is very clear, and you have a narrow peak at 720, which proves this is a real leaf. So this is a very simple exercise to show you that spectrally, in the spectral dimension, you can do some chemical analysis of the nature of the objects you are imaging, which is the purpose of hyperspectral. In the sense of you can image, of course, for agricultural application, you can image with drones, or in tractors you can image the fields, but you can also do this on skin imaging, you can do this on chemical objects for recycling, and in machine vision in general.